In this session, we try to solve a problem on Hilbert transform. Find Hilbert transform of the signal g of t is equal to sinc of t. That means we are going to find Hilbert transform of sinc signal. So in the first step, we are going to use frequency domain approach. In the first step, let us write the signals in time domain and its Fourier transform in frequency domain. From our fundamentals of mathematics in the previous semester, sinc function Fourier transform is a rectangular function. So it is depicted as follows. So this rectangular function exists from minus half to half here on frequency axis. So in step 2, we need to find g cap of f, that is Hilbert transform of g of f. Since we have selected here frequency domain approach, after finding g of f, we have to find the Hilbert transform of this function. Therefore, Hilbert transform of g of f is given by h of f into g of s. G of f, that is nothing but multiplication in frequency domain. What is h of f? It is nothing but minus j signum function. What is g of f? G of f is nothing but rectangular function. So in step 3, we are going to write the equations for signum function and rectangular function we have obtained. So signum function is defined for positive frequencies +1, for negative frequencies -1, for 0 it is 0. Similarly, rectangular function is defined for the value of f greater than -half, less than half, it is 1 and 0 otherwise. So after plotting the signal in step 4, let us try to plot signum function and rectangular function. So after plotting the signal, now in step 5, in order to obtain this g cap of f, we need to multiply this signum function along with this g of f. So here I have written signum function. Below that I have written rectangular function. When I multiply signum function with rectangular function, so I am going to get g cap of f. That is nothing but intermediate signal we'll get. So it is existing from -half to half, because here you are going to see 1 into 1 is 1 up to 0 to half. After that we see 1 into 0 is 0. Similarly, here also on negative side you are going to see -1 into 1 is -1 up to -half. After that it is 0. So in step 6, now we are going to define the Hilbert transform by considering signum function value. So g cap of f is given by minus j signum function into g of f. Already we know what is g of f. G of f from the previous step, it exists from -half to +half. Therefore, now we are going to write the equation for g cap of f. So g cap of f is given by minus j for frequency greater than equal to 0, less than equal to half, j for frequency greater than -half, less than equal to 0. That means you are substituting signum function value. For f greater than 0, it is 1, therefore minus j. For f less than 0, it is -1. -1 into minus j is plus j here. So in step 7, we are taking inverse Fourier transform of this g cap of f. Therefore, in time domain, if you take inverse Fourier transform of g cap of f, we get time domain signal, that is g cap of t is equal to inverse Fourier transform of g cap of f. What is g cap of f? It is nothing but minus j from 0 to half into e to the power of j 2 pi ft into df plus minus half to 0, what is the amplitude j, into e to the power of j 2 pi ft df. Now simplify this. It is nothing but minus j divided by j 2 pi t. So integral of e to the power of j 2 pi ft is e to the power of j 2 pi ft by j 2 pi t. So substitute the limits here and here also. So now you simplify, you will get the answer 1 by 2 pi t plus 1 by 2 pi t minus 1 by 2 pi t into e to the power of j pi t plus e to the power of minus j pi t. So this is in the form of e to the power of j theta. So we have to use trigonometric equation. So now simplifying, 2 by 2 pi t minus 2 cos pi t by 2 pi t we will get. How we get this answer? E to the power of j theta plus e to the power of minus j theta is nothing but cos theta plus j sin theta plus cos theta minus j sin theta. So plus j sin theta minus j sin theta get cancel each other, you will get 2 cos pi t. So substitute here. So 2 gets cancelled, here also 2 gets cancelled. You can simplify and write the answer of Hilbert transform of g of t as 1 minus cos pi t by pi t.